antimicrobial resistance. This is Staph, the bacterium. He's not like the rest of his family. You see, while all his thousands of siblings have the same DNA, his is different. His DNA was supposed to be replicated to be the same as everyone else's. However, the little chemical workers, DNA polymerase enzyme, putting together DNA, accidentally made a mistake and the wrong nucleotides were put in.
We know that bacteria replicates by binary fission. In this process, there are two identical daughter cells produced from the parent cell. Sometimes random mutations can occur. These mutations are really just mistakes that have been made during the process of DNA replication. Instead of replicating the DNA strand exactly, some sections of nucleotides get changed, resulting in a slightly different DNA sequence. Often, this affects how the gene is expressed, and the bacteria may have new characteristics due to this mutation. This random mutation meant that Staph's genes coded for new proteins that changed some of his characteristics. In this way, bacteria can randomly mutate to gain characteristics that allow them to be resistant to antibiotics. They might now be able to prevent the antibiotics from binding to the cell wall to destroy it, or it may begin to producing alternatives to essential proteins that antibiotics usually destroy. Although even though Staph was different, he didn't mind so much. Him and his family were happy in their home at Elbow. Even when their family grew big, and some moved down to the wrist, while others moved up to the shoulder, they had plenty to eat. However, Bob wasn't too happy with all the bacteria that were causing the itchy and blistering infection on his arm. He went straight to the doctor and was given antibiotics. Within days, the antibiotics found their way to Staph's family. They had all sorts of weapons and were able to destroy the cell wall of the bacteria, all the way from shoulder to wrist, that they fought a bloody war one by one, killed every single bacterium they found. Every bacterium, that is, except one. Staph survived. His mutated gene meant that the antibiotics weren't able to attach to him and therefore hurt him. If these mutated bacteria are exposed to antibiotics, they will be able to survive, while most of the initial DNA sequence will die. This is what happens when we take antibiotics. Most of the bacteria causing sickness will be targeted and killed, allowing us to feel better. However, a few lone bacteria which have evolved resistance mechanisms will survive. So there he was, a lone survivor in his empty homeland. But Staph was not sad. He was very angry. He began to build up his family again, replicating his DNA, creating thousands of new bacteria through binary fission. Not only will Staph now be able to survive, but he will be able to pass on this resistance as he keeps on reproducing and replicating his DNA. He can even exchange sections of DNA plasmids or T-strand spoons, including those holding resistant genes, with other non-related bacteria through a process called conjunction. This means that his resistant genes can now be passed around the population
very quickly.
When Bob's arm started to get itchy again, he went and got more of the same antibiotics. This time, however, the bacteria were ready. The antibiotics were useless against bacteria who had resistance gene, and Staph prevailed. Bob's arm didn't stand a chance. But Staph didn't just stop there. He and his family spread all over the hospitals, to new lands, from ears to lungs to toes, and every time a new, higher-tech antibiotic was used against them, random mutation was on their side, allowing them to develop and spread new resistant mechanisms against each and every type of antibiotics. At last, having defeated every antibiotic thrown at them, Staph's great-great-great-great-great-grandson remains standing tall and strong. Golden Staph.